Today, we're going to learn how to find the volume of a region revolved around an axis. Consider a right cylinder with a base of circle with a radius of 2 units and a height of h is equal to 3 units. We all know that the volume of a right cylinder is the product of its area times its height. Now, the area of the base is pi r squared, since our base is a circle. Pi r squared times height. Then we substitute the value of our r and h. We have pi 2 squared times 3. We have 3 times 4, 12 pi cubic units. Now remember this answer, since we're going to compare this to our next solution. Now let's sketch the right cylinder into a three-dimensional coordinate system with its axis coincidental with the x-axis right here. Now remember, take note that the volume of a right cylinder is just area stacked in height of h. For example, right here we have a lot of areas right here. Imagine areas of circles stacked in height of h. Then this is our area pi r squared. When these areas are stacked in a height of h, we have our volume pi r squared times height. But we can also imagine a rectangle. When rotated or revolved around an axis, we can generate a right cylinder right here. Now, because I've mentioned that a rectangle when revolve an axis generates a right cylinder, then we'll consider a rectangle right here with a length of 3 and a width of 2. Take note that when this rectangle right here is revolved around an axis, for example in this case the x-axis, we can generate a cylinder. And take note also that the length of our rectangle right here is the same as our height of our cylinder, and the radius of our rectangle, or the width of our rectangle, is just the same as the radius of our cylinder. Now we're going to use this to find the volume of the cylinder. First, let's make an equation for this one. This equation, this vertical line right here, is x is equal to 3, because for any values of y, we will have the same x, which is 3. That's why we have our equation x is equal to 3. And let's define this one, this horizontal line right here, as our f of x. Our f of x is equal to y is equal to 2. Since for any values of x, we will always have the value of 2 for our y. That's why our f of x is 2. Now we're going to use that to find our volume. We have our formula pi r squared, which is the length of our r is just the same as the length of our f of x. That's why we substitute f of x for our r. That's why we square our f of x in finding the volume. And our height is just the same as the length of 3 units. Now we substitute our value for our f of x, which is 2 squared times 3. We have 3 times 4, we have 12 pi cubic units, which is the same answer as before. Now, it's easy to look at it as rectangle revolved around an axis, but what if our function is not a horizontal line like this one? What if it's not horizontal line like this one? What if our function is not constant? What if our function is like this one, a parabola, a a slanting line right here with a slope of positive number not equal to 0. Now let's define this one as our f of x to find the volume of a region revolved around an axis. Now let's make an infinitesimal or very small rectangle right here with length of dx and with width of f of x. It's very small that this one right here becomes horizontal. And let's define our differential volume. The volume of our rectangle revolved around the axis. When this small rectangle right here is revolved around an axis, we can create a disk. We'll create a disk like this one. If we revolve this one, we'll create a disk with radius of f of x and with height of dx. That's why our differential volume relates to our formula pi r squared. R is our f of x. That's why we're going to square the f of x for our differential volume, and we multiply the dx because it's simply the height. Now that's our differential volume, the volume of a very small rectangle when revolved around an axis. But what about the whole region when revolved around an axis? Now let's gonna draw more rectangles right here and sum all of those volumes up. Now how are we going to sum those volumes up? We just integrate our differential volume to find our whole volume when these rectangles all are revolved around the axis. We have integral of dv, we have v is equal to integral of pi f of x squared dx evaluated from a to b because those are our limits. Now since pi is constant, we can move that out from our integral. That's why our volume becomes pi integral of f of x squared dx evaluated from a to b. Now if you forgot that formula, just remember a very small rectangle that when revolved around an axis, that it has a radius of f of x and it has a height of dx. That's why the differential volume is just pi f of x squared times dx, and then integrate that to sum all those volumes of those small rectangles. Okay, that's it. That's our formula for the volume of a region bounded by the function f of x evaluated from a to b. That's all.